there, Karen. So with regards to your question, the most simplest way I can think of to break it down is to think about the X and Y components of your flight. Okay, so you know that you have your desired route. And since they give us information about the speed, or sorry, not the speed, the distance and the time, you can use that to equate the speed. They also give you direction. Then you give you information about the wind, and what you're really looking for is this pink portion, which is flight. Okay, so I've already taken the liberty to draw out the information based on what they've given us in the problem and use that to set up our overall process. Okay, so with the flight portion, we don't know what that is, so we're going to just label that as our just simply F, and it's going to have an X and Y component. Okay, so with that, here we go. Let's focus on just the X portion. Okay, so we know that there's a flight, there's the wind, and the route. So with the wind, that is going to be with a speed of 25 miles per hour. They say that it's southeast, so that means that this angle to the positive X, if you will, is going to be 45. Okay, when I'm dealing with the X portion, that means, of course, I'm dealing with cosine. So I've got 25 cosine of 45 degrees. Here we go. And that's going to equal to my route heading with, it's 90. And the cosine I'm going to do here is not going to be that 9.4 degrees. So it's actually referring to this part. That's the 9.4 degrees. So I'm going to use a complementary angle because I'm talking about the positive X. And so that's going to give me 80.6 degrees. Okay. So that's 80.6 degrees. Okay. So I'm going to use this and calculate out, figure out what my X component is. I'm going to do something similar with the Y. Part that's going to be slightly different here is that if you look, my wind is actually with a positive X component and a negative Y component. So instead of adding 25, I'm going to be subtracting 25 using sine, of course, because we're talking about the Y, 45 degrees. With the route, I do not need to worry about doing any kind of switcheroos or changes because it is positive in the X and Y direction. So it's just going to be simply 90 sine. I am looking at 80.6 again because that is the complement to my given angle. Okay, so once I do these two, I can then calculate, I can solve for the X component and the Y component of my flight. Once that's done, then I can go, cool, I know how to find the magnitude, right? So we're just going to do our Pythagoras friendly base equation. So I'm going to take this, I'm going to square my X component, I'm going to square my Y component, add them up and square root them. Okay, so it's going to give me the speed of my flight. And then when I'm looking for the angle, okay, I'm going to be using tangent. And if we call, let's say we're dealing with flight, so I'm going to just call this angle that I'm looking for, it's going to be beta. Okay, so it's going to be my flight angle. It's going to be based on, just simplifying it out, the Y component over the X component. And once I do that, that angle is going to tell me the measure that I need to use to talk about my direction. Now, if we need to take this direction and adjust it so that we are talking about north, east, west, and south, it's pretty simple and straightforward. If you have questions on how to do that, feel free to reach out to me and I'll be happy to walk you through it. All the best, and I hope this video helps.